friends, in previous lectures we have seen some basic integrals. Now we are going to study the integration of a functions using trigonometric formulae, or we can say that the integrals which include trigonometric functions. For that we have to know the list of formulas useful for the integration. So see, in a picture there are important trigonometric formulas are there. You can note that. From that we have some important trigonometric formulas created or formed by rearrangement of formulae. Please note all that formulas. Okay. Write down example. Evaluate the integration of first one integral integration of cos square of x. Suppose we have to integrate cos square of x. Now first thing, remember that we can't find the integration of quadratics, cubic or power function in trigonometric type. So we have to convert this given function into the linear form. Okay, for that we have to go through the formulae, and in that rearrangements we will get the formula what is 1 plus cos of 2 theta. Such a formula is there, 1 plus cos 2 theta. This is nothing but 2 cos square of theta. The relation is here is double angle and this converts to single angle. Okay, from this we can find only value of cos square of theta. Shifting this 2 to left hand side, this will give us 1 plus cos 2 theta divided by 2, or rearranging these terms we can write 1 by 2 into 1 plus cos of 2 theta. Okay, this is equal to cos square of theta. Now using this formula we can write this integral, or in further integrals for our convenience we can write in answer the given integral as I means integral cos square of x dx. Now using formula for this cos square theta is nothing but 1 by 2 into 1 plus cos 2 theta. Using that formula we can write 1 by 2 in bracket 1 plus cos of 2x, because here is theta is variable and here variable is x. We have to integrate with respect to x. Okay, now see here. Okay, cos of 2x. Now we can say that taking 1 by 2 constant outside of integration and taking term by term integration of these two terms, notice this step: integration of 1 with respect to x, taking 1 by 2 constant outside of integration or bracket, plus integration of cos 2x dx. Okay, in previous video we have seen the integration of composite function like this. This is one standard integral. What is integration of 1 by 2? What is integration of 1 with respect to x? This will give us x. Remember here what is integration of 1, and what is here integration of cos 2x. What is integration? Here two composite functions are there, one is cos, second is 2x, and here taking integration using the theory of composite functions, integration of cos is sine, angle putting as it is 2x, divided by derivative of this function 2x. What is derivative of 2x? That will be 2 plus some constant of integration c. This will be the final integral I. Or you can again multiplying this 1 by 2 to the both terms, you can rearrange that, or you can put this function as it is. Again we can rearrange the answer in such a way, taking this 2 common from both the terms, we can write here 1 by taking 2 from denominator common, 2 into 2 will be 4, and due to taking common these 2, the effect will be here 2x plus sine of 2x plus c, or you can rearrange the answer in number of ways. Okay, this is first one example. Okay, let's see second one example. Integration of sine square of 2x with respect to x using the same theory as previous problem. We have the formula, what is 1 minus cos of 2 theta. This will give us 2 sine square of theta. Now remember the relation here. Here is double angle, this converts it into single angle. Okay, or we can say that here is single angle, it gives us double angle in linear form. Using same theory, we can say that here is double angle, and again shifting this 2 to left hand side, we can write this sine square theta is nothing but 1 minus cos 2 theta. We have to find the value of sine square of, suppose 2 theta, suppose variable is theta. Then if here is single angle, here will give here, it will give here double angle. If we are taking here double angle already, it doubles here, or we can say here cos of, here double of 2 theta is 4 theta divided by 2, and using this formula we can now integrate the given function, denoting it by integral I. This is sine square of 2x. Okay, now see, this is equal to, using this formula, can I write here, taking this 1 by 2 here, and what will be the 1 minus cos of 4x with respect to x. Now taking 1 by 2 outside of integration and taking your separating integrals, integration of 1 with respect to x minus integration of cos of 4x with respect to x, completing this bracket. Next 1 by 2, what is integration of 1 is x minus what is integration of cos 4x. Integration of cos is sine 4x upon 4 plus c, using the composite integral. This will be the final value. Okay, note down the problem. Okay, next integral, integration of root of 1 minus cos x dx. Again we have the formula, what is 1 minus cos of 2 theta. Remember, this is basic equality. Using this we can convert the angle. This gives us 2 times sine square of theta. Okay, and shifting this 2 here, or rearranging, this is sine square of theta, 1 minus cos 2 theta upon 2. We will use this formula in future. Okay, now remember the relation. Here is 2 theta in our problem, here is single x. Okay, can I write then 1 minus cos of only single x is there. If here is 2 theta, this gives us single theta. If we are taking here single x, okay, then we can write, or we can put this 2 as it is here. 1 minus cos x can be written as 2 sine square of, here is 2 theta, here is half of that term, here is x, and half of that x will be x by 2. Okay, using this formula we can write the integral I, putting that 1 minus cos x dx, and then integration of what is 1 minus cos x. This will give us root 2 sine square of x by 2 with respect to x. Now here, as here is multiplication, we can separate the root, or we can write root 2 as a constant and taking the outside of integration. What will be in root here? Sine square of x by 2 with respect to x. Now cancelling this square and square root, we will get here root 2 in integration sine of x by 2 dx. Now here again we will get here one composite integral, and simplifying this composite integral we will get root 2 into what is the integration of sine. Integration of sine function is minus cos, angle putting as it is, divided by derivative of x by 2, derivative with respect to x of x by 2. Remember that derivative I will write here. What is derivative of x by 2? Derivative of x is 1, 2 being constant putting as it is, this is 1 by 2 here, plus some constant of integration c, and rearranging the last step here, we can write this denominator will shift to numerator, and multiplying these two terms we will get here minus 2 root 2 into cos of x by 2 plus c. This will be the final answer. Okay, remember the steps. Next integral, evaluate integration of in bracket tan x plus cot x bracket square dx. Okay, now here we have to first expand this given term using a plus b bracket square using this formula. This is a square plus twice ab plus b square. Okay, using that, first of all I will write this is integral I tan x plus cot x bracket square and expanding given function using a plus b bracket square. Okay, a is tan x, b is cot x. Can I write here tan square of x a square plus 2 times a into b, that is tan x into cot x. Okay, plus b square, that is cot square of x. Now remember, here we have to use some trigonometric formulas to simplify this problem. Okay, here is one equality we can use here. What is tan of theta, tan theta into cot theta? These are reciprocals of each other and gives us 1. Okay, we can put here. And remember, here we can't find the integration of square functions, and we don't have any formulas like sine square theta and cos square theta to convert the given problems into linear form. But we have again formula for tan square theta using the standard equalities. Standard equality is there, 1 plus tan square theta. What is value of 1 plus tan square theta? This is sec square theta, but shifting this plus 1 to right hand side, we can see here what is tan square theta, sec square theta minus 1, and converting this we have the integration of sec square x. Standard formula is there, and we can again integrate 1. Similarly, what is cot square of theta? Cot square of theta is nothing but cosec square of theta minus 1 using third standard equality. Okay, now can I write here what is tan square x? Tan square is nothing but sec square of x minus 1, because variable is x here, plus 2 into what is this total term? This total term is 1. 2 into 1 will be 2, plus what is here again? Cot square theta. Cot square of theta is nothing but cosec square of theta, here is x minus 1. Okay, bracket complete here, dx. Now this total value is 2, and this minus 1 will give us minus 2. Minus 2 plus 2 will get cancelled here, and what is the remaining term? This is only sec square of x, and we can separate these integrals, dx, plus what is here? Cosec square of x, cosec square of x dx. Okay, and what is integration of sec square x? Integration of sec square x is tan x, plus what is integration of cosec square x? This is minus cot x. Okay, plus some constant of integration c, and rearranging this final answer, can I write tan x plus minus will become minus cot x plus c, and this is result, final value. Okay, next integral, evaluate integration of cos 2x upon sine square x into cos square x dx, and denoting this integral by I, we will get here cos of 2x upon sine square x into cos square x dx. Okay, now here we can convert this cos 2x, numerators cos 2x, because we have the formula for double angle, what is cos of 2 theta, and converting this cos 2x, we can separate numerator and denominator, so we can further simplify the problem. Remember the steps. This is what is cos of 2 theta, the formula for double angle of cos in terms of sine and cos, that is cos square theta minus sine square theta. There are 4 forms of cos 2 theta. From that we have to use only formula in terms of sine square and cos square. Okay, and using that formula, can I write here, this is cos square of x minus sine square of x divided by sine square x into cos square x. Okay, and with respect to x we have to integrate. Now separating numerator and denominator, can I write here cos square x, sine square cos square divides cos square x, and again sine square x. Then separating these terms we can write sine square x into cos square x. Next is minus sine square x divided by sine square x cos square x. Okay, taking here bracket, with respect to x we have to integrate. Now some terms will get cancelled. This cos square, as here is multiplication, we can cancel this sine square cancelled, and what is remaining term here is 1 upon sine square of x minus 1 upon cos square of x dx. Okay, now what is 1 upon sine square? 1 upon sine square gives us cosec square x minus 1 upon cos gives us sec square x, and we know that we have these are standard integrals. What is integration of cosec square x? This gives us minus cot x minus what is integration of sec square x? This is tan x plus c. You can take this minus sign common, or we can put this answer that I is equal to minus cot x minus tan x plus c. Okay, next integral, integration of cos cube of x with respect to x. Okay, cos cube x is there. Now we have formula for triple angle cos of 3 theta. From this formula we have to rearrange, or we have to find only value of cos cube of theta. For that we will make some arrangement. Shifting this term to right hand side, we will get here cos of 3 theta plus this minus will become plus here cos theta. This is equal to 4 cos cube of theta, and again shifting this 4 to the left hand side, this multiplies here, this will divide here, or we can write here 4. Okay, what is cos cube of theta? Cos 3 theta plus 3 cos of theta divided by 4. And using this formula, can I write here cos cube of theta is nothing but converting this cube power, cube function into the linear one. We will get this formula. This is cos 3x plus 3 cos 3x plus 3 cos x divided by 4 dx. Now this 4 being constant can be taken outside of integration, and what will be, we have to take integration of cos 3x and 3 cos x. I am putting here bracket integration of and separating the integrals cos 3x dx plus 3 being constant can be taken outside of integration, integration of cos x dx. Okay, I'm completing this bracket. Remember or notice this step what I did here, that separating integrals and taking 1 by 4 constant outside of integration. Now this is simple one, this is composite integral. What is the integration of cos 3x? This is sine of 3x upon 3 plus 3 being constant can be taken outside of integration. And what is integration of cos x? Integration of cos x is sine x plus some constant of integration c, and you can take this 3 as common, or you can multiply this total term by 1 by 4. Now taking this 3 common, we can say 4 into 3 is equal to sine 3x, and due to this common term we will have here effect, taking here multiplying by 3, this will be 9 sine x plus c, and rearranging this term 4 into 3 will be 1 by 12 sine of 3x plus 9 sine x plus some constant of integration c. This will be the final answer. Okay, this will be final answer. Okay, next integral, evaluate integration of sine 3x into cos 5x dx. We know we can't integrate the functions or product of functions directly, so we have to convert this product into sum or difference. Okay, we have this formula 2 sine a into cos b. This converts the product into addition, sine a plus b plus sine a minus b. Only we have to shift this 2 to right hand side. As 2 multiplies here, it will divide here. Okay, then we can write here this sine 3x into cos 5x can be written. Remember what is a here? A is 3x. What is b? B is 5x. So can I write here this 1 by 2 in bracket? Okay, what is here? Sine a plus b. This formula you have to learn this formula. What is 2 sine a into cos b? This is sine a plus b plus sine a minus b. Only shifting this to this will sine a plus b here. Sine what is a? A is 3x plus b is 5x plus sine of a minus b. What is a again? A is 3x, b is 5x. Completing this bracket, taking integration with respect to x. Note this step. What is here? Sine of 3x plus 5x plus sine of 3x minus 5x dx. Now 1 by 2 being constant can be written outside of integration. This is, and what is in integration? What will remaining terms here? Here sine 3x plus 5x. Adding these two terms, this will be 8x plus what is here next? Sine of 3x minus 5x. This is minus 2x. Okay, with respect to x. Now what I am rearranging here is negative angle. What is sine of minus theta? This property of negative angle, sine of minus theta is nothing but minus sine theta. Using this property, can I write here integration of sine of 8x minus sine of 2x dx. Okay, now we have to take integrals, separating integrals. Here integration of sine 8x with respect to dx with respect to x minus integration of sine of 2x. Okay, now only we have to take integration of these composite integrals. What is integration of sine 8x? Integration of sine is minus cos angle as it is 8x divided by derivative of 8x, that will be 8 minus what is here again integration of sine function is again minus integration of sine is minus cos 2x upon 2. Here is derivative of 2x 2 plus c. Now we have to only rearrange these terms, taking here 8 common. Okay, or we can say this is 1 by 2 in bracket minus cos 8x upon 8 minus minus will become plus this cos 2x upon 2 plus c. This is final answer. Or we can take 8 as a common, and taking 8 as a common and rearranging the answer, we can write 1 upon taking 8 is common, 2 into 8 will be 16. Okay, here is minus cos 8x, and as we are taking here 8 common, it will affect here 8 divided by 2 will be plus 4 cos 2x plus some constant of integration c, and this will be the final answer. You can write this is again final answer. You can say this is nothing but final integral. Next integral, evaluate integration of cos x square of x degree. Remember, whatever we have studied formulas are there, that all formulas are, we are saying what is integration of sine x. This x is given in radian. Remember this. Here we have given the angle in degree. So first of all we have to convert this degree into radian. We know the formula for conversion, degree to radian conversion. For that conversion we have to multiply that x by pi upon 180. Okay, and this is the angle in radian. So using this we can write integration of cos x square of what is pi upon 180 into x dx. Okay, this is radian here. We now integrate. What is integration of cos x square x? This is minus cot x. Okay, cos x square of x, but angle is here. This angle is composite here. Using the rule of composite integration, what is integration of cos x square of pi upon 180x? This is cot of pi upon 180 angle as it is x divided by derivative of pi upon 180x, and we know what is derivative of kx. This pi is constant, 180 is constant into x. Derivative of kx is k, like the derivative of pi upon 180 is This is pi upon 180 plus c. Now rearranging this term, we can write shifting this 180 to numerator minus 180 upon pi into cot of pi upon 180 x plus c, and again we can convert this degree, sorry, this radian into degree, or we can say minus 180 upon pi into cot of x degree plus c, because pi upon 180 x is nothing but x degree plus c, and this is our final answer. Okay, for homework I am giving you the list. Please do practice that example.
In next video we will see the methods of integration. In that we will see the integration by substitution. Thank you.